Hello, my name is Christopher. I'm a senior developer at AiQu, and in this video I will show you how to queue a job on the AiQu platform. Uh, so if we start here at the jobs page of the AiQu platform, and you scroll down to add job to queue, this is where the parameters are put in for queuing a job. So I'm gonna go through each of these fields and tell you what they mean. So if we start here with the job label, this is the name of the job. Uh, it's arbitrary from the view of the system, but it can be useful to have some kind of a descriptive name so you can find the job later. So you can really put anything here. I'm just gonna put test job. So the next field is the GPU. So this is the number of GPUs that you want. So a smaller job can have fewer GPUs, and if you have a very large workload, then more GPUs can be assigned. You can also choose to have no GPUs if you only require CPU power. For my case, I'm gonna have one GPU. The next is the CPUs, and this is the number of CPUs that your job should have. You can also choose the automatically choose, which assigns you a number based on how many GPUs you have. So if you have all the GPUs, then you will get all the CPUs, and if you only have half of the GPUs, then you only get half of the CPUs. So it assigns you a decent number based on the GPUs you have. So I'm gonna do the automatically choose, and it's the same for the RAM memory. You can either choose your own size for it if you know what you need, or you can do automatically choose and get a decent chunk of RAM. So the next field is the runtime. This is how long your job will be running. In the case of an interactive queue, as we can see here that I have, if it's not an interactive queue, then the runtime will be grayed out and will be disabled. Because the non-interactive queue or the batch queue is the job is running for as long as it needs. In that case, the command is required instead, and when the process that is started at the command is over or has run out, then the job will terminate. So it will automatically detect when the job is finished. But in this case, it's an interactive queue, so I need to put a time. So I'm just gonna take 45 minutes. I think that will be enough. And for the next is the Docker registry and the image. So I have a few registries. You can do the choose automatically, and then we'll try every registry to find your image, or you can put a registry. So for example, you have the NVIDIA container registry. So you can choose any image from that registry, or Docker Hub, choose any image from there. In my case, I'm just gonna use one of the ones that I've previously used. So I'm gonna choose the NVIDIA TensorFlow image with TensorFlow version 2. We can also see some base images that are defined from the system. Can also be useful, but any image can be inputted here as long as you know the path to it in the Docker Hub or the NVIDIA container registry. So the command is next, and for an interactive job, It's simply a command that is run after the container is started. So for example, if you want to install some kind of package, you can do it from here. You could do something like this to install Jupyter. In my case, I'm gonna do that in the container later, so I'm just gonna leave that blank. For ports, this is the ports that will be open inside the container. So for example, the 8888 is the default Jupyter notebook port, which I will be running in this demo. So I'm gonna leave that and also add port 22, which is the SSH default port. And those two are the ones that I want for my container. So the next one is folders to mount. So this is the external storage. Everything inside the container is ephemeral and will be removed when the container is stopped, except for this external storage. So it's always a good idea to mount something to your container so you can save any job output or data or scripts or anything that you have been working on. So in my case, I'm gonna choose the home catalog and mount it to /data inside the container. And the next one is the advanced settings, as we can see here. And these are the environment variables that you can set inside the container. I'm not gonna use it for my job, but I'll set one just to show how it looks. I'm just gonna set test to 1, 2, 3. And we also have the forget flag, which if you need to set a password or something that you don't want to be saved later, then you can push to forget here. So after the job is over, it will be deleted entirely from the system. And if we have a view at the right side here, we can see the queue that the job will be queued to. A queue is a collection of nodes. In this case, it's only one node, but it can be many different nodes inside a queue. We can see the total available GPUs in this queue or on the node that is in the queue. So in my case, there's 4 out of 6 GPUs available. And the same for the total available CPUs and memory. And this is good to have a glance at when you are filling out your resources parameters. For example, I can see that I can only put 126 as maximum for it to start right now. So if I, for example, would put 150, I would see that it would start in 13 days instead, since we have some long-running jobs that are using a lot of CPUs. So it's a good idea to have a look at that and just see that the resources that you request are actually available. So I'm going to choose the automatically choose one. Next, we have the project, which is a collection. You can see that if I switch to this, the token balance is changed to the project token balance. And anyone inside the project will be able to see the job and interact with it. And all the tokens drawn will be drawn from the project token pool instead of your own pool. I won't be using that. I have my own token balance. So we also have the estimated cost of the job. So this is the amount of tokens that will be drawn from it. It can be changed in the future, mostly if you yourself extend the job later if you put down more time for it. But this is what it should cost based on everything you have put in. And then we have the estimated start time with this, which is simply when the job is expected to run. So I'm gonna queue this. And we can see here that it was put in the queue and it is starting soon. We can see all the different parameters here and more if we put in, go to the job details page. Here we can see the ports that will be opened and the mounted folders, the CPUs, memory, the job environment that we have set, estimated end cost, token spent right now, which is 0 because it hasn't started yet, and also some other fields that we will show more in different videos. So this job will be starting now. It has gone into the starting. It just went to running. So here we can see that it is running and it has been it has 44 minutes left in the remaining job time. We can also see that we can extend the time. So we can put, if we need more time, we can put 1 hour more and then extend it. We can't always extend it since someone can have booked a job with that GPU for later. But if it can be extended, we try to make that possible at least. So let's go ahead and open the ports. We have a few options here. We can open it publicly, and then it's a straight TCP session. It's just an open port that you get access to. There's very little security from our side on it. We have an IP filter that I will show you when we open it. But otherwise, it's up to the user to secure the port from inside the container. We also have the open private option, which is the safer option, but only works with HTTP. So if you, for example, have Jupyter Notebook, then open private is the correct option since it will open a HTTPS relay where it first checks if you actually have access to that port. So for example, you need to be logged into AiQu to be able to view that port. So it's a bit safer. So I'm gonna go ahead and open both of these ports. The 22, which is the SSH, will need a public since it's not HTTP in the backend. And this comes with a little warning that will expose the port to the internet. So you need to be sure of what you're doing and need to have some security in the backend at least. So I have opened it here and I can see that I have an address and a port for connecting to that port inside the job. Right now there's nothing running on it, but we will soon be starting some processes for that. You can also see the IP filter, which per default puts in your own IP address. So only you can connect to it. So if you need to have multiple people connect to it, then you can just remove the IP filter, just leave this blank and then set filter. But since I'm the only one that's gonna access this, then I'm gonna leave it. And for the last port, we open it privately, and then we get an HTTP URL instead of just the port. And IP filter is not available for this since it's already secured in other ways. But since there's nothing running on the job, I'm gonna go ahead and start some processes there and start SSH and Jupyter. So I start a web terminal to the job. And since I mounted all my data inside /data, I go there and I can see that I have AiQu utils in here. And if we take a quick look at the files, I can see that it's the same as this one. So this is the one that is mounted inside the container. And if I, for example, create a file, let's just do test123, then I can see that there, it was in the main folder. So it is reflected inside the external storage. So let's go into the AiQu utils folder where I have a few scripts for initializing a Jupyter notebook and SSH. So I'm gonna start with SSH, and this script requires a username and a password. So I'm just gonna set test and test123. I will wait a bit for that to install. This one will add a user, add a sudo, and then start SSH. So that's completed. So now I'm going to start the Jupyter notebook also. So there we go. So now I can connect to the SSH since it started. I'm gonna bring up a terminal here and we can see. I'm gonna paste this in. And then I'm gonna SSH to that address and that port. And oh yeah, of course, I need the user that I added inside the container instead. So I'm gonna write test and test123. And now I'm inside the container. I have the same view as I did in the web terminal. So I can see here the files that I had defined. So now we can see if, yeah, the Jupyter is started. So now we can navigate to that address and get a Jupyter Lab notebook here. I also have an GPU trainee notebook, which I'm going to run in the background just to generate some synthetic load. So I'm gonna start that here. And this is not something that I have created. It's just used for generating load from inside a container. So that is how you connect to a Jupyter Notebook and SSH, and of course you can use any kind of ports that you need. You can put up your own web server if required and present something here, or put up a tensor board or anything like that. We don't really have any limits for what you can put in there. And with SSH, you can also connect to Visual Studio Code. So I can show you here how that looks. I'm just gonna bring up my Visual Studio Code here. So I have my config here with the relay.iq.ai. So I'm gonna need to put in what I set up my container with. So I set it up with test, and then I'm just gonna use the port here that I received from AiQu, and then save it, and then connect to that job. And then I need to put in test 1, 2, 3. And then it's connected, and it shows us /data here also. So I can see all the scripts that I have and the test file that was created earlier. And now we can see that there are some load generated in the container. The notebook has started to train, and we can see the GPU usage is rising, and we can also see the GPU usage here inside the job details page and see the graph of it. And also we can see it in the overview for how much load there is. We can choose the node, and we can remove everything except the GPU 5 that I think is the one that is connected to my job. We can see here that it is using a bit of resources. So that was everything I wanted to show you in this video. Thank you for watching.